Hey guys, I'm on section 4.3. So now we have what is the anticipated geometric sequence and series. So the first 2 days of the chapter we spent doing arithmetic sequences and series, which is when you add or subtract a certain number each time. But a geometric sequence and series has a common ratio, aka it's when you multiply each term to get the next term. So there's a very basic example. You're just multiplying by 2 each time. So it's not a set addition or subtraction thing. It's multiplying, and that makes it a geometric sequence. So if it's not obvious, like in this case, it's obvious that the numbers are doubling, so the R is 2. If it's not obvious, like some of these examples down here, then you can always take a term and put it over the previous term. So any term you want, like the 5th term, and put it over the 4th term to see what the ratio is. So like 2nd term over 1st term, 3rd term over 2nd term. That's how to find it out if it's not obvious, okay? That'll come up. Here's the formula for a geometric sequence to find the nth term. So if it's a different type of sequence, if it's not arithmetic, if it's geometric, we have a different formula for the nth term. So here's where all those formulas are going to come into play. And just one thing to keep in mind, this is a multiplication symbol right here. So you take your first term and multiply by the ratio times or to the n minus 1. The biggest mistake people make here is not doing order of operations. So remember, you can't multiply these together until you take care of the exponent first. So remember your order of operations. Let's use some really strong algebra skills here. We also have geometric means. Same thing as arithmetic means. It's just terms in between any two non-consecutive terms, but of a geometric sequence. So we'll practice that as well. The last thing is we have another formula for the sum. So we have formulas for arithmetic sequences for the nth term and for the sum. We have 2 of them for geometric as well, for the nth term and for the sum. So here it is. And again, be careful with the exponents here. You can't subtract 1 minus r and then raise it to the n. You have to do r to the n first and then do 1 minus that answer. So keep in mind those algebra skills. All right, so what I want you guys to do first, I'm going to write out, it's just practicing finding the first common ratio for each one. So like, what are you multiplying by each time? Or the other answer could be, what are you dividing by? It's the same thing as multiplying by a fraction, right? So see if you can figure out what those common ratios are and use the formula above if it's not obvious to you. So I'm just going to pause the video and fill out these 5 as like a warm-up. And I encourage you to pause the video and see if you can just find what's the common ratio for each one. All right, guys, so here's what I came up with. So this very first one you might be recognizing right away as dividing by 4, but keep in mind that a common ratio is what are you multiplying by. So dividing by 4 is the same as multiplying by 1/4. So if this formula is going to work, you got to use the 1/4 as the r. This one's a little bit more obvious. You're multiplying by -2. The ratio is allowed to be negative. That's okay. In this case, we are multiplying by 4. It's easier to look at these 2 or maybe even these 3 to be able to tell that. But 7 over 16 multiplied by 4, the fraction reduces, gives you 7 over 4. So the ratio here is 4. In this case, again, we are dividing by t to the 3rd. So that means we are multiplying by 1 over t to the 3rd. So whatever you're multiplying by is the ratio. For number 5, it wasn't as obvious for me to figure out what are you supposed to multiply by. Maybe for you it is. You can look at the 2x and look at the negative 10x and be like, oh, well, that's multiplied by -5. You could also look at the -1 and the 5, the whole numbers, and that's also multiplied by -5. If you couldn't come up with it as obvious, then what you can do, remember the trick that I wrote above. You can take the 2nd term divided by the 1st term. I did that here. There's stuff that cancels and factors and you're left with -5. Just to check to see if I didn't make a mistake somewhere, I then tried the 3rd term divided by the 2nd term. You can take the previous term and divide it by, or a term number and divide it by the previous term. That'll work for you. So in that case, stuff factored and canceled here and I still got -5, and that is why my ratio there was -5. All right, let's move on. That's just practice finding the r. So let's try using the formula. So in this case, find a1 if we're given a11 and r and all that stuff. So just remember, start by writing the formula. And if you write it every time you start a problem, you'll have it memorized before you even know. How did I know to write this formula and not the other one? Big clue is that this is given an r. If it was an arithmetic sequence, we would be given a d. I'm going to write a quick note about that. I know it's geometric because of R. If it was an arithmetic one, that would be a D. Okay, just keep that in mind because we are going to be using all these formulas at once on quizzes and tests. So it says A11 is 972, so I can plug that in for A sub n. I don't know what my A1 is, that's what I'm trying to figure out, but the R is radical 3, and the n is 11. Okay, so this is a little bit messier. That should be a 2, by the way, right here. Okay, so what I have to do now is like do this radical 3 to the 10th, I guess. 972 equals a sub 1 radical 3 to the 10th. Well, if you remember from Algebra 2, radical 3 is the same as 3 to the 1/2. Remember that from Algebra 2? And then keep the 10 exponent. So we got to use a lot of good Algebra 2 skills here. When I do 3 to the 1/2 to the 10th, you multiply these exponents here and it gives you 3 to the 5th. So 972 equals a to the 1st times 3 to the 5th. Notice how I'm following order of operations. I'm dealing with the exponent here before you multiply. So exponents always come before multiplication. 3 to the 5th is 243. So 972 equals a sub 1 times 243. That gives you a sub 1 equals 4. There's our answer, okay? Let's look at number 2. We've got a similar situation where I have a formula. I'm supposed to find R and a sub 1, and I'm just given 2 different terms. So remember what we did in class when we did this problem together? I wrote one equation using that stuff, and I'm going to write a second equation using this stuff. Okay, so plug in all of your numbers that you know. So A3 is 36. That means that my third term is 36. Don't know what A1 is or R is, but I know that n is 3 minus 1. So 36 equals a sub 1 R squared. That's my first equation. I'm going to do a substitution or elimination thing when I have 2 variables. Let's work with this side also. Negative 121.5. I don't know what A1 is. I don't know what R is, but in this case the n is 6. So I get R to the 5th. Okay, so how do I do substitution or elimination if it's not addition and subtraction, if it's multiplication here? So these do look a little bit different. I think what I'm going to do is solve this equation for A1, so divide by R squared on both sides. That's going to get rid of this, and I can plug all of this in for a sub 1. So negative 121.5 equals 36 over R squared times R to the 5th. And yes, that's going to simplify pretty nicely. R to the 5th divided by R squared is R to the 3rd. If you divide both sides by 36 first, don't cube root first. We got to get rid of that 36. That's going to give us negative 3.375 equals R to the 3rd. Now you can cube root both sides. Same thing as raising both sides to the 1/3. And yes, remember you are allowed to cube root negative numbers. It gives you negative 1.5 equals R. Thank God I found R. Now plug it in somewhere, wherever you think is the easiest place to plug in. Maybe to me right there, because you can type it all into your calculator at once. And that is going to give you a sub 1 equals 16. So there's our substitution or elimination thing. You can be given 2 terms and you can still figure out what the A1 is and what the R is. I'm going to go through number 3 pretty quickly because you're given a sub 5 and you're given the R and it asks for the first term. So again, good habit, write down the formula first. Plug in everything you know. A sub n is 1 over 144. I don't know what A1 is. That's what I have to solve for. 1/3. The n is 5 in this case. So 5 minus 1 is to the 4th. 1 over 144 equals a sub 1 times, how do you do 1/3 to the 4th? Well, you do 1 to the 4th and also 3 to the 4th, and you end up with 1 over 81. The way to get rid of that 81 is to multiply 81 on both sides. And yes, that fraction reduces, and you end up with a sub 1 equals 9 over 16. So really quick problem on that one. Number 4, write a sequence with 2 geometric means in between those two numbers. So remember how we set up the arithmetic means problems? We put 12 in between a blank and another blank and 4/9. And remember we did like plus D plus D plus D. Well, in this case, we're multiplying by something. So it's times R times R times R. Since it's a geometric series or means, I know that I'm using R and not D. And I know I'm multiplying and not adding. And so just be careful when you're writing your equation like this. When you start with 12, and if you multiply by R 3 times, that's not 3R. Let's be good at algebra 2 here. R times R times R is actually R to the third. And that gives me 4/9. So that's my equation that I'm setting up here. So I can first divide both sides by 12. And that fraction is going to reduce when I divide by 12 and get 1 over 27. And then again, you cube root both sides. How do you cube root a fraction? You cube root the top and the bottom. You end up with R equals 1/3. Okay, and so now that I have my 1/3, I'm just literally going to take my 12 and multiply by 1/3. So when I take that 12 and multiply by 1/3, I get 4. When I multiply that by 1/3, I get 4/3. And when I multiply it by 1/3 again, I end up with 4/9. So I nailed it. All right, I think number 5 is going to be the last one I'm going to go into. It is a little bit of a longer day of notes, so I'm going to split it up into part video, and then I'm going to finish the rest of it in class. But find the sum. So important key word here is now we're not finding the nth term, we're finding the sum. So I actually have a sum formula for these. S sub n equals a sub 1 minus r to the n over 1 minus r. Make a quick note and make sure you've got this n with the r and not on the outside of the parentheses. So that's a really common mistake that people make. And it's the sum of the first 7 terms. So I don't have to write out all 7 of these, but I'm probably going to need to plug in whatever numbers I know. I'm trying to find the sum of the first 7 terms. I know the first term is 14. I can do 1 minus, let's figure out what the ratio is. What am I multiplying by each time? I believe it's -5. Yes, that's why the signs are alternating. -5, that means my r is -5. Here's where algebra skills are going to come in handy again. I have to do this -5 in parentheses, that's what the ratio is, to the nth, which means to the 7th, over 1 minus -5. You have to be really careful with your negative signs. It's very common. You cannot cancel these. You first have to do the exponent and then do 1 minus whatever that is. So just be very careful algebraically here. Okay, so calculator's handy. I'm keeping everything the same so far. Did you know that -5 to the 7th is -78125? Since that exponent is gone, yes, now I can do my plus positive thing, okay? 1 minus -5 gives me 6 in the denominator. And so then when you crunch that number in the calculator, you end up with a pretty big number, and that number is 182294. Okay, so again, write the formula, plug in whatever stuff you know. The moral of the story here for this sum formula, most common mistake here is putting the exponent in the wrong spot, or algebraically not dealing with the exponent first and then keep everything the same, so then it ends up being double negative. In the case of this being an even exponent, that would make this negative go away, and this would become a positive number here, so it would be 1 minus a positive number, which would give you a negative number in here. So you just have to be really careful with those negatives. All right, let's move on with number 6. So sum of the first 8 terms. So again, I'm noticing right away that I have a ratio here of, this looks like √3. If you multiply by √3 again, yes, this means my r is √3. That's kind of weird, but hey, just going to go with it. I'm going to write my formula, the sum of the first 8 terms. So that means sum of the first 8 terms equals, I'm still using the formula from above. It's the a1, which is 2. And then 1 minus, what is the ratio again? It's √3 to the 8th over 1 minus root 3. So again, same formula that we wrote above. The a1 goes first. That's 2 in this case. A sub 1 means the first term. I need to find the sum of the first 8 terms. The ratio here I decided was root 3. A little bit harder to see with radicals, but that's okay. The exponent is 8 right here. Make sure you put it here and not outside. It is only with this ratio here. And then 1 minus r goes in the denominator here. Okay, so this is a little bit strange, but I am going to algebraically be really careful here with my radical. So if you remember, do you remember that root 3 is the same as 3 to the 1/2? And then I can make that 8. I got a little bit crazy with all my parentheses there, but that's okay. So root 3 is the same as 3 to the 1/2. And then if I do that, this algebra becomes really easy. This just becomes positive 3 to the 4th. So it's 2, 1 minus 3 to the 4th over 1 minus root 3. Okay, so sometimes changing radicals into fraction exponents makes your algebra a little bit easier, so just keep that in mind. Those are just little tricks and tips for you. So anyways, 2, 1 minus, did you know 3 to the 4th is 81? So here's an example where we ended up with an odd, or an even number here, which is going to give us an odd number in the parentheses. 1 minus root 3. You can give that a calculator equivalent if you want to, but 2 times negative 80 is negative 160. And then I'm just going to leave the 1 minus root 3 in the denominator. Algebraically, there's a lot of ways to equivalently express that. I would say you do not have to go through and rationalize and do all of that. You can just leave your problem like that. Just keep in mind, if it were a multiple choice question, there are equivalent ways of writing this as an answer, so you might have to rationalize, or you might have to change to a decimal or something like that. You should be able to pick the right answer in the case of a multiple choice question, okay? All right, moving right along, there's a couple more questions here that we have to talk about this new thing called summation notation. This is pretty exciting. But writing in summation notation, this is a Greek symbol. It's a sigma, and it stands for the sum. So notice how all of these are being added together, and that is a short abbreviation of saying add all of this stuff together. And so I think in this case, one of the tricks or things that's going to make this a little bit easier is if you number these. This is my 3rd term, this is my 4th term, etc. Can you figure out what you are multiplying by each time? It looks like 2. So that's good to know. And the way that we're going to write this summation notation is you write this big sideways E thing. It means find the sum of all of the terms. And these are my n's up here. Remember, n means term number. So this is the first term is 3, the second term is 6, the third term is 12, etc. And so I'm going to start with my very first term, n equals 1, and I'm going to go all the way until, how many terms am I adding up here? This one goes forever, so I need to put an infinity sign. So I'm going to put stopping at infinity. This is the way that you start setting up your summation notation. That means find the sum of all of the terms starting with the first term to forever, and then I need to write the formula right here. Do you remember how to come up with a formula for the geometric sequences and series? So it's a1 r n minus 1, and so I'm just going to fill in my a1 and my r, starting with the first term going to forever. This is getting into some calculus, you guys. This is really exciting. My first term is 3. My ratio is 2. And I'm going to leave n minus 1 as the exponent. So I'm leaving it as n minus 1 because it's going forever. I don't have an ending term number. And so that's why I'm just leaving what's in the formula, which is n minus 1. So this is the way that you write a pattern that looks like this in symbol notation. This is major calculus, you guys. Let's try another one. So here is another symbol, and in this case they're giving me all of the formula with all the symbols and everything, and they're asking me to, even though there's no words here, this symbol means sum. I need to find the sum starting with the first term, ending with the 10th term. I do not want to take the time to write out a t-chart 1 through 10 and add all those numbers together. So I believe we have a formula for this, if you remember. The sum formula starts with a1, and it goes 1 minus r to the n over 1 minus r. And so in this case, what's cool about the summation notation is that this 4 is your a1, the 3 is your r, and this says start with the first term by plugging in 1 and end at the 10th term. So this gave us a lot of information. So the first term is 4, so I'm going to plug in 4 for a1. I have 1 minus, the ratio is 3, to the n is 10, because that's my stopping point, my 10. I'm going from the first term all the way to the 10th point, so the 10th term is going to be my n. I'm going to divide by 1 minus r, which is 3. So in this case, again, we just have to be careful about algebra. And I'm just going to pop this thing into my calculator. Just have to be really careful with that minus 3 to the 10th. It's not negative 3 to the 10th, but when you type this thing in, you should end up with 118,096. So give that a shot in your calculator. You do end up with a negative on top because it's 1 minus 3 to the 10th. 3 to the 10th is a really big number, and when you do 1 minus that, you get a negative number on top. And then this is a negative 2 on the bottom, which is why our answer ended up being positive. Try typing that into your calculator. I would just, instead of typing 1 minus 3, I would just type negative 2 as the denominator just to make it a little bit more simple. Okay, we've got one more, you guys. The sum of the first n terms is this. For this series, find the value of n. Okay, I am seeing a sum, so I have a sum formula for that, and I can recognize pretty quickly that I'm timesing by 4 each time, etc. So that means that my r is 4, so I know this is a geometric formula. So in this case, I told you guys we are so formula heavy in this chapter. If you're okay memorizing formulas, then you're going to be just fine. This is my last example, but the sum formula, again, if you write it before you do any problem, you're going to have it memorized really, really quickly. So this is our formula for sum. In this case, I'm just going to plug in all of the stuff that I know. I don't know how many terms. That's what I have to solve for. So all the n's I'm going to leave blank. But they're telling me that the sum, the answer, when I add everything together, is 32,766. I also know a1 is 6. 1 minus r. Oops, I know the r also. The r is 4. I don't know the n. Okay, interesting. Now let's use some mad algebra 2 skills again. Okay, so first of all, I think I can probably change this into negative 3. That's going to make it a little bit more simple. And I'm probably going to times both sides by negative 3 in order to cancel the negative 3. So this is basic algebra so far. Hopefully I haven't lost anybody. This takes me to negative 98298 equals 6 times 1 minus 4 to the n. Okay, let's divide both sides by 6. That's something that I could do pretty quickly also. And that's going to give me negative 16383 equals 1 minus 4 to the n. Okay. Still just trying to solve for this n. I know it's in the exponent, so that's going to be a little bit tricky, but I can probably subtract 1 from both sides too. So I'm going to get negative 16384 equals negative 4 to the n. Dividing both sides by negative 1 changes these to positives. Okay, this is weird. Okay, how about if I take this thing called a log or a natural log of both sides? Isn't that what allows me from algebra 2 to bring this down in front? Oh snap. So natural log in the calculator, 16384 equals n times natural log of 4. So if you remember from algebra 2, you guys, that's the entire purpose of logs and natural logs, is to solve for an exponent. When you take a log of both sides, remember, whatever you do to one side, you have to do to the other. But taking the log of both sides brings this exponent down in front, and now this is just a decimal in the calculator, and this is also just a decimal in the calculator. So now we have a decimal equals n times a different decimal. So I just need to divide both sides by ln4 divide by ln 4, and actually type this into your calculator with me, because remember, just like square roots and stuff, whenever you do a natural log, it's going to open up parentheses, so you need to close the parentheses. Just be careful about that. When you do ln 16384 divided by ln 4, you get 7, which is pretty cool. You could also use the regular log button. It works the same way. I just use ln because it's one less letter that I have to write. Okay. Let me breeze through that example one more time just in case I lost you. So we were asking for the sum, or we were given the sum, which is this. So that's what my equation equals. I don't know what the n is, but I know when I add up all of the numbers up until a certain number, the total is 32766. And my first term was 6. My ratio was 4. We already talked about that. So I plugged everything in and I simplified the denominator first. That became -3. So then I essentially cross-multiplied, same thing as timesing both sides by -3. And that canceled my denominator, and then I divided by 6, and then I subtracted the 1. This is just all Algebra 1 stuff so far, you guys. And I end up with 16,384 equals 4 to the n. And how do you figure out what n is? I guess you could guess in your calculator and go 4 times 4 times 4 times 4 until you get this number. But you could also much faster just take the natural log of both sides, and that is what allows the exponent to come down in front as a multiplier. And then you just have a little bit of calculator work to do, and you end up with n equals 7. So hey, you guys, I know that was a lot. This is a long video. I apologize, but I got through all the notes, and if you have any questions on homework stuff, please reach out to one of your teachers or me. Okay, thanks for watching. Have a great day.